Good morning everyone, good morning. I welcome you all again to the NEET Elite. Hoping that you guys are doing great. Well, I'm sorry I was a bit late. There were some technical issues going on, that's why. Well, you can let me know in the chat box if I'm audible and visible to everyone. You can let me know in the chat box if I'm audible and visible to everyone. I'm doing great, Swapnil, I'm doing great. How are you? Welcome guys, welcome. Welcome back to NEET Elite, yeah? Exactly. Perfect. So you can just give me some green signal from the chat box so that I can start the session directly, yeah? Just give me some green signal from the chat box so that I can start the session directly without wasting a lot of the time. Perfect, guys, perfect. I'm doing good. How are you guys doing? You had a long break of 2 days, yeah? And I'm sure you would have revised everything, every single session, every single question, yeah? I'm sure about that. Can you let me know in the chat box how many of you revised this chapter till now in these 2 days? Can you let me know in the chat box? I just want to see actually how many of you revised the mole concept. Let me know in the chat box. Perfect. Great. Wonderful, guys. Great. Okay, so as you all must be knowing, today it's going to be the next session from the same topic, concentration terms, right? In the last session of concentration terms, we talked about something called as weight by weight percent, weight by volume percent, volume by volume percent, and at the end, we talked about something called as mole fraction, yeah? So these were 4 terminologies which we covered in the last session, okay? So before starting today's session, let me introduce myself for the ones who are new to the channel. My name is Wassim and I'm your chemistry master teacher right here on this channel, okay? Perfect. And for the ones who have not liked the video yet, please do like the video, share and subscribe the channel as well. And do not forget to hit the bell icon so that you get the notification of every single session which I'll be taking right here on this channel, okay? Perfect. So let me know in the chat box if you guys are super duper excited for the session, which I always say in every session, yeah? You can let me know in the chat box if you guys are super duper excited. Thank you, Rashu, thank you. You can let me know in the chat box. You can let me know in the chat box if you guys are super duper excited for the today's session, yeah? Let me see the Josh of the session first, then we'll be starting the session. Exactly, yeah? Perfect, guys, perfect, wonderful. Wonderful. All right. Okay, so let's get started with the term called as molarity, yeah? Let's get started with the term called as molarity. Before starting the molarity, let me tell you what all things which we discussed till now in this concentration terms. I hope you remember, we are done with something called as weight by weight percent. We are done with something called as weight by volume percent. We are done with volume by volume percent as well. And at the end, if you remember in the last session, we talked about something called as mole fraction. So these were the 4 terminologies which we covered in the last session. And in the today's session, we are going to talk about something called as molarity and molality. Yeah? So let's get going. Let's get started. Let's see what this molarity is all about. Yeah? First of all, people, I'll be writing its definition. Then I'll make you understand what this molarity is all about. Yeah? Let me write its definition. Simplest definition I'll be writing. Okay? The first thing, this molarity, it's represented by capital M. Okay? Molarity is represented by capital M. And how do we define it? See guys, I'm writing it over here. It's defined as the number of moles of solute, present in 1 liter of solution. Present in 1 liter of the solution. Molarity is defined as the number of moles of solute present in 1 liter of solution. Yeah? How can we understand this concept? See guys, See, as per the definition, molarity of the solution, it's defined as number of moles of solute present in 1 liter of the solution. Okay, understand it like this. For example, I have got a container right here, and in this container I have kept a solution. I have got a solution in this container, right? Let's assume volume of this solution I'm sorry. Let's assume volume of this solution right here is 5 liters. 5 liters is the volume of solution, for example. Okay. And for example, in these 5 liters of solution, let's say we have got 10 moles of solute. We have got 10 moles of solute, right? See, as we all know, solution has 2 components. One is your solute, one is your solvent, right? Now, what I have taken over here, I have taken a solution, and I'm assuming volume of this solution over here is 5 liters. And in these 5 liters of solution, we have got 10 moles of solute. This is something which I'm assuming over here. Yeah? Now see, people, in this scenario, can I say something like this? Can I say 5 liter of solution? Can I say 5 liter of solution contains 10 moles of solute? Contains 10 moles of solute. Yeah, I can say this, right? As per this scenario, as per the solution which we have in the container, we have got the solution whose volume is 5 liters and there are 10 moles of solute present in it, right? So what I'm saying right here is, as per this scenario is concerned, I can say 5 liter of solution contains 10 moles of solute, yeah? So can I say 1 liter of solution contains 10 divided by 5 moles of solute, right? I can say this, yeah? Right? So 10 divided by 5, it comes out to be 2. So can I say something like this? Can I say I got to know 2 moles of solute are present in 1 liter of solution? Yeah? I got to know 2 moles of solute are present in 1 liter of solution. And we know the number of moles of solute present in 1 liter of solution, that's what we call as molarity, right? Correct? So this 2, it is basically the value of molarity of the solution, right? Simple, guys. As per its definition is concerned, molarity is defined as number of moles of solute present in 1 liter of solution. Over here, I took a solution whose volume was 5 liters. And in these 5 liters of solution, I'm assuming there were 10 moles of solute. That's something which I've written over here. I've simply said 5 liter of the solution contains 10 moles of solute. That means 1 liter of solution will be containing 10 divided by 5 moles of solute. That means 2 moles of solute, right? Or in simpler words, I can say 2 moles of solute are present in 1 liter of solution. And the number of moles of solute which will be present in 1 liter of solution, that defines the molarity of the solution, correct? So I can say right here, molarity of the solution is equal to 2. Molarity of the solution is equal to 2. Or you can say simply, 2 moles of solute are present in 1 liter of solution, correct? I'm sure till here it's clear to everyone, yeah? Similarly, if I'm saying I've got a solution whose molarity is 5, what does it mean? If I say I've got a solution whose molarity is 5, what does it mean? It simply means 5 moles of solute. It simply means 5 moles of solute are present in 1 liter of the solution, yeah? Very simple terminology, correct? It simply means 5 moles of solute are present in 1 liter of solution, yeah? Correct? Correct? Now let's try to make its formula. Or before making a formula, for example, I've got a solution whose molarity is 10. What does it mean? It simply means 10 moles of solute are present in 1 liter of solution. Very simple and basic term, right? Exactly, guys, exactly. Now understand, how will I be making the formula out of it? Understand properly. See, guys. So this 10 divided by 5. These many moles of solute are present in 1 liter of this solution over here, okay? This is something which I call as molarity of the solution, right? This is something which I call as molarity of this particular solution, correct? Now, if I want to make its formula, understand, what is this 10 over here? This 10 over here in the numerator, these are the moles of solute. What is this 5 over here? 5, this is the volume of solution in liters, right? So I can make its simple formula as let me erase it till here, or let me make it over here only. I can say molarity is equal to, in the numerator we have got number of moles of solute, right? I'm writing it over here. Molarity is equal to number of moles of solute divided by, in the denominator there is 5. What is this 5? This 5 liter is the volume of solution. So divided by, I'll say volume of solution but in liters, right? This is one important formula by means of which we can calculate molarity of any solution. Yeah? I'm sure this is clear to everyone, right? I'm sure this is clear to everyone. Now understand few more important things about this molarity. Understand properly, okay? So till now, what we got to know? We got to know molarity, it's defined as number of moles of solute present in 1 liter of solution, yeah? And we got the formula of molarity as number of moles of solute. I hope you remember, number of moles of solute we note down by N2 divided by volume of solution in liters. Be careful with the terminologies. This is the volume of solution. This is the first formula by means of which I can calculate molarity of the solution, okay? Number 1. Number 2. Understand. I can write the same formula in a different way as well. I can write it like this. What is this N2 over here? N2, these are the moles of solute, right? N2, these are the moles of solute. Can I say moles of solute will be basically equal to mass of solute divided by molar mass of solute, right? N2, what is N2? Number of moles of solute, which is going to be mass of solute divided by molar mass of solute, as per the simple definition of mole is concerned. And in the denominator, you have got volume of solution in liters. This is one more formula which you can use at times to calculate the molarity of the solution. Yeah? Okay. Let's try to make one more. Have a look. Understand. Let's say I've got a solution. Whose volume is 10 ml. Let's say I've got a solution whose volume is 10 ml. If I want to convert this volume into liters, what am I supposed to do? I'm supposed to divide it by 1000, then only I'll be getting the volume in liters, right? See, I had a solution whose volume was 10 ml, correct? I just divided this 10 ml by 1000, we got the volume of the solution in liters, yeah? As simple as that, correct? Now people understand. I've got a solution whose volume is VML. Now, if I divide this by 1000, can I get the volume of same solution in liters? Yes, I can say this. Right? Correct? If I divide the volume of the solution in ml by 1000, I get the volume of same solution in liters. That's what I'm going to do now. Understand. Over here, this is the volume of solution in liters. So volume of solution in liters, instead of this term, can I replace it by this one? Okay. So what I'll be getting something like this. Molarity is equal to, see, in the numerator, you have got mass of solute, W2, divided by M2 is the molar mass of solute, multiplied by. Instead of volume of solution in liters, I'll be writing volume of solution in ml divided by 1000. So it's going to be volume of solution in ml divided by 1000. That 1000 comes up, so it becomes 1000 in the numerator, right? This is one more formula which you guys can use in order to calculate molarity of the solution. And frequently, I'll be using this one and this one to calculate molarity of the solution, correct? I'm sure this is clear to everyone, okay? Be careful with the terminologies. Again, I'm telling you. What is this W2? W2 is the mass of solute. What is this M2? M2 is the molar mass of solute. What is this V over here? V is the volume of solution in milliliters, right? But in this formula, in the above formula, this V right here, it is the volume of solution in liters. In the second formula, it is the volume of solution in liters, but in this one, it is the volume of solution in milliliters, right? Can you just let me know in the chat box with some thumbs ups if you got the concept so that I can move on and talk about a bit more about this molarity? Can you let me know fast? With some thumbs ups? Bowleen, physics will start soon. Physics teacher is not well basically of this channel, okay? He'll be joining back. Perfect, guys, perfect. Nandita, you can just drag the video a little back. It'll be automatically a replay for you, okay? Just drag the video a little back, watch the replay. It's going to get cleared. Right? Perfect, guys, perfect. Okay, again, I'm telling you one more thing. Let's say I've got a solution whose molarity is equal to 100. Can you let me know what does it mean? I've got a solution whose molarity is equal to 100. What does it mean exactly? It simply means 100 moles of solute It simply means 100 moles of solute are present in 1 liter of solution. Yeah, 100 moles of solute are present in 1 liter of solution. Correct? I'm sure you're clear with these basic things about this molarity right now. Okay. Now, people, one more important thing. See, understand. There are few terminologies which you might find in the questions. You'll find something written like this in the questions. You'll find a solution and it's going to be written as semi-molar solution, right? Semi-molar solution. You can find out one more terminology in the question, okay? There is something called as decimolar solution. There is something called as decimolar solution. There is something called as centimolar solution. Centimolar solution. And there is something called as millimolar solution as well. Millimolar solution as well. Okay? These terminologies you might find in your questions, okay? What all things can we predict from it, okay? Understand. Semi-molar solution is that solution whose molarity is 0.5. Okay. Decimolar solution is that solution whose molarity is 0.1. Centimolar solution is that solution whose molarity is 0.01. And millimolar solution is that solution whose molarity is 0.001. Simple. These things you are going to remember, okay? Right? Hot chat will be doing that as well. Just wait for it. Okay, these are few things which you are going to remember. Semi-molar solution is the one whose molarity is 0.5. What does that mean? That means 0.5 moles of solute are present in 1 liter of solution. Simple. Decimolar solution is that solution whose molarity is 0.1. That means 0.1 moles of a solute are present in 1 liter of a solution. Yeah. Centimolar solution, it is that solution in which 0.01 moles of solute will be present in 1 liter of solution, and millimolar solution, it is that solution in which 0.001 moles of solute are present in 1 liter of solution. Yeah? Let me know in the chat box if all these things are clear to you. Let me know fast. Right? Let me know fast. Perfect, guys. Perfect. One more important thing which I would like to share with you. What is that? See guys, if you look at any of the formula of molarity, see, this is molarity, this is volume of solution in liters, this is molarity, this is volume of solution, right? This is molarity, this is volume of solution. Everywhere you have volume of solution. But in the first two formulas, this is the volume of solution in liters. In the last formula, it is the volume of solution in milliliters. In general, can I say molarity everywhere, it's inversely proportional to volume of solution? Molarity is inversely proportional to volume of solution. Okay? Molarity is inversely proportional to volume of solution. What does that mean? That means if you increase the volume of the solution, what happens to molarity of the solution? Molarity of the solution will decrease. Very simple. Yeah? This simply means if I increase the volume of the solution, molarity of the solution will decrease. Similarly, if I decrease the volume of the solution, molarity of the solution will increase. Correct? Now people understand. What is this V over here? V is the volume of the solution. And remember, volume of the solution depends on temperature. Volume of the solution depends on temperature. Now people, can I say something like this? Molarity of the solution depends on volume of the solution. Volume of the solution depends on temperature of the solution. Can I say molarity of the solution will also depend on temperature of the solution? Yeah? Molarity of the solution, it will also depend on temperature of the solution. Correct? Right? Molarity of the solution, it simply depends on temperature of the solution. Remember it, okay? Or I can write a statement over here. I can say molarity is temperature dependent. Molarity is temperature dependent. What does that mean? Is temperature dependent, okay? What does it mean? I can simply say molarity of the solution changes on changing the temperature of the solution. Yeah? I can clearly say molarity of the solution changes on changing the temperature of the solution. Correct? Hot chat, I didn't start IUPAC nomenclature, bro. I started GOC from the direct inductive effect. You can check it out in the playlist. Right? Correct. Let me know in the chat box if it's clear to everyone. Remember, molarity is temperature dependent. Okay, on changing the temperature of the solution, molarity of the solution automatically changes. Okay, I'm sure this is clear till now. Let's move on. Let's get going. Let's see the other things about this molarity. Okay, understand. If I ask you one more thing, what are going to be the units of molarity of the solution? If I want to write the units of molarity, see, molarity is basically equal to number of moles of solute divided by volume of solution in liters. In the numerator, you have got moles. Yeah. In the denominator, you have got volume of solution in liters. So moles per liter, or you can say moles liter inverse, it is going to be the unit of molarity. It's going to be the unit of molarity, right? Molarity has got the unit as moles per liter. Understand this as well. This is again very important. Okay, moles liter inverse, or you can call it as moles per liter. It is simply the unit of molarity. Correct? Now let's see what type of questions are asked from this concept of molarity, right? Understand what I'm going to say. This is something which I told you, correct? Okay, one more important thing, guys. One more important thing. Remember this as well. Remember this as well. See, understand what I'm going to say. See, few minutes back I told you molarity is equal to number of moles of solute divided by volume of solution in liters, correct? Right? Well, people, from this formula, can I write like this as well? Can I say number of moles of solute N2 is always equal to molarity of the solution multiplied by volume of solution in liters, right? Okay, so you got one more direct result from here. This simply means if I have the solution, right here, whose molarity is M, for example. If I've got a solution right here whose molarity is M, and let's assume its volume is V liters, volume of solution is V liters. If I'll simply multiply these two terms, I'll be getting the number of moles of solute, as simple as that, yeah? If I simply multiply these two terms over here, I'll be getting the number of moles of solute, right? Because number of moles of solute is equal to molarity of the solution multiplied by volume of solution in liters, okay? For example, I've got a solution whose molarity is 3, whose volume is equal to 5 liters. Let's say I've got a solution whose molarity is 3, whose volume is 5 liters. If I divide these two things, 3 multiplied by 5 comes out to be 15. This means I have got 15 moles of solute present in this container right now. It simply means this. I've got 15 moles of solute present in this container right now. Okay. Let's say I've got the solution whose molarity is 10, whose volume is 5 liters. What does it mean? If I simply multiply these two things, I'll be getting the number of moles of solute present in this container. It simply means 10 5s are 50, 50 moles. 50 moles of solute are present in this container right now. Yeah? All these things I can get from here. Number one. Number two, guys. Understand one more important thing. See, number of moles of solute is equal to molarity of the solution multiplied by volume of solution in liters, right? Yeah? Now see. If I replace this volume of solution in liters by volume of solution in milliliters, matlab, if I write this formula as molarity of the solution multiplied by volume of the solution in milliliters, now I won't be calling this term as number of moles of solute. I'll be calling it as number of millimoles of solute. Remember this thing as well. This is important, which I'll be using in the next session basically, okay? When I'll be teaching you molarity of dilution and molarity of mixing, these two things I'll be using there. Remember, whenever I'll be having a solution whose molarity is M, whose volume is V liters, if I divide the two things, I get the moles of solute, right? If I replace the volume of solution in liters by volume of solution in milliliters, and then I divide these two, I get something called as the number of millimoles of solute, okay? Remember this important thing over here. Okay, why it's important? You'll get to know the importance of this in the next session. Right? Let's move on. Let's talk about a few more interesting things. Understand. This is the first basic question which you can solve right here on molarity. And I'm sure you guys are going to kill this question. Trust me on that. Okay. See guys, what is mentioned in the question and what we are supposed to calculate as per the question. Understand properly. Calculate the molarity of the solution containing 80 grams of NaOH in 200 ml of, you can write it as aqueous solution. In 200 ml of aqueous solution, correct? Yeah. See then, look at the question. Krishna, I'll be starting the series for 11 to 12th, maybe next week, not in this week, okay? Next week I'll be starting 11, or maybe in this week only I'll be starting. Let me check the schedule, okay? I'll check the schedule, I'll get back to you. Yeah? Vedantu student class 10. Sir, when is your class 11th JEE Pro batch starting? It's starting most probably this month only. I don't remember exactly the date. Tarun, I've not taught the laws of combination yet. That is least important, okay? Oh, all right, look here guys, look here now. Calculate the molarity of the solution containing 80 grams of NaOH in 200 ml of aqueous solution. So basically I have got an aqueous solution. Whose volume is 200 ml. So I have got an aqueous solution whose volume is 200 ml, correct? So first data which I got to know, volume of solution is equal to 200 ml, right? Well people, this aqueous, what does this AQ stands for? This aqueous stands for water, right? This simply means I have put NaOH into water, right? This simply means I have put NaOH into water, correct? So what is this NaOH right here? Can I say this NaOH is my solute over here, okay? And can I say this is the mass of solute? Mass of solute, all of you must be knowing, that is something which I represent by W2. So W2 value right here is 80 grams, okay? Now if I ask you, what is the molar mass of this NaOH? What is the molar mass of my solute, which I'm representing by M2? It's simply going to be 40 grams per mole. Yeah, this is the molar mass of NaOH. What am I supposed to calculate? I'm supposed to calculate molarity, yeah? I'm supposed to calculate molarity. So I'll be writing molarity of the solution is equal to W2 multiplied by 1000 divided by M2 multiplied by volume of solution in milliliters, right? So can I just put the values? Have a look. W2, mass of solute over here, which is 80 grams, multiplied by 1000, divided by molar mass of solute is 40 grams per mole, multiplied by volume of solution in ml. Volume of solution in ml. How much it is? It is simply 200, correct? So this is 1, this is 2 times, this is 1, this is 5 times. Sorry. The value comes out to be 10, correct? So people, you got to know molarity of the solution right here is 10. Okay. So what do we mean by this term? We got to know the solution has the molarity 10. What does it mean exactly? Can I say it simply means 10 moles of solute are present in 1 liter of solution? Can I say it simply means 10 moles of NaOH are present in 1 liter of solution? Yeah, I can say that. Correct? Mac, I didn't check it. You can text me back, okay? You can text me today back. I didn't check it. Correct? I'm sure this is clear to everyone. Molarity of the solution I got to know as 10. This simply means 10 moles of solute, which is my NaOH, are present in 1 liter of solution. As simple as that, yeah? Right? Perfect, guys. Perfect. Now, let's move on. Let's talk about few more interesting things. Okay? All right. Let me write it over here only. One more direct result I'm giving you guys so that you can solve the questions in lesser time. One more direct result I'm giving you, okay? Right? What are those direct results? Say. Put the heading as calculation of molarity when weight by weight percent of solute. Weight by weight percent of solute is given. Remember this as the direct result which I'm giving you, okay? There will be some questions in which you'll be given with weight by weight percent of solute and you'll be supposed to calculate molarity of the solution. Okay, there will be some questions in which you'll be given with the weight by weight percent of solute and you'll be supposed to calculate molarity of the solution. For those questions, I'm going to give you the direct result. No need to use your brain or something. Use the direct result, done, right? Say, remember the formula, molarity is equal to 10 multiplied by density of solution multiplied by weight percent of solute, divided by molar mass of solute. Okay, this is one direct result which you guys will be using in order to calculate molarity of the solution if weight by weight percent of solute is given to us. Okay, remember this as the direct result. Okay, Well, I can convert this result in a different form as well. I can convert the same result in a different form as well. If you remember, in the last session I told you weight by volume percent of solute, weight by volume percent of solute is equal to weight by weight percent of solute multiplied by density of solution. I hope you remember this. Yeah? In the last session I gave you this result as well. Well, people, understand properly. See, this is weight by weight percent of solute. Over here is density of solution. Weight by weight percent of solute multiplied by density of solution. Do we call this as weight by volume percent of solute, right? So I got one more result. I can write it like this, 10 multiplied by. Instead of these two terms, I can simply write weight by volume percent of solute. Weight by volume percent of solute divided by molar mass of solute, correct? This is one more result which you need to take a note of. You'll be using these two results in the form of questions, okay? These are two important results right here. Ritika, this is English channel. I'm not supposed to talk in Hindi. I'm really sorry. Okay. Well, we have got other channels in Vedantu as well. Okay, in which teachers talk in Hindi. So you can join that channel. But this channel is particularly for the ones who cannot understand Hindi. Yeah. I'm sure you got it right. Yes, flying Sandra. The syllabus is almost same, but the level of difficulty in JEE is more than that of NEET. Kunal, let's see. Nikhil, that is least important. Whatever I'm teaching you right here in this chapter, only those things you have to understand. That's it. No need to go for any other things which are written in your NCERT. You'll find something written as precision, accuracy, those significant figures. Don't leave that aside right now. Whatever I'm teaching over here, just remove this thing. Okay, and try to solve the equations based on the same concepts which I'm giving you right here. Okay. Perfect, guys. Perfect. Let's move on. This is something which I already told you. Semimolar solution is the one whose molarity is 0.5. Decimolar solution is the one whose molarity is 0.1. Yeah. Centimolar solution is the one whose molarity is 0.01. Okay. And millimolar solution is the one whose molarity is 0.001. This is something which I told you a few minutes back. Correct? Yeah. All right. We have got one more question, I guess. Right. We have got one more question on the screen. We can solve this one as well. Right. See, guys, how this question is to be solved. Understand. Again, a very simple question. Surely, Isma, I'll be doing that. See, calculate the mass of NaCl required to produce 100 ml of semimolar solution, or you can mention it as semimolar aqueous solution. Okay. First of all, understand few important things from the question. Calculate the mass of NaCl required to produce 100 ml of semimolar aqueous solution. Aqueous solution means my solvent is water. Right? And in this water, what we have introduced? We have introduced NaCl into water, right? So my solute over here as per the question is NaCl. Correct? These are two things which I got to know. Now, calculate the mass of NaCl. That means I'm supposed to calculate mass of solute. Mass of solute is represented by W2. I'm supposed to calculate the value of W2 actually. Yeah. Required to produce 100 ml of solution. Correct. Volume of solution is given to me, guys. It's given to me as 100 ml. Correct. And I'm given with one more thing. I've got this semimolar solution, right? I've got a semimolar solution. I've got a solution whose molarity is 0.5. Yeah. All these things are given to me. At the same time, I'm given with the solute, right? That's NaCl. You all must be knowing what is the molar mass of solute, what is the molar mass of NaCl. You can calculate that, 58.5 grams per mole. I can say that, right? Well, we are done. Almost, right? What I'll be doing simply is, I'll be writing the formula for molarity. Molarity is nothing. W2 multiplied by 1000 divided by M2 multiplied by volume of solution in milliliters, right? What am I supposed to calculate exactly? I'm supposed to calculate the mass of solute, right? I'm supposed to calculate the value of W2. Okay. Well, people, molarity of the solution is given to me. It's given to me as 0.5. Yeah. Molarity is given to me as 0.5. W2 we are supposed to calculate multiplied by 1000 divided by molar mass of solute is given to me as 58.5. Volume of solution in milliliters, it's again given to me as 100. So you got one simple equation in which you have got one variable, that is this W2. You can calculate the value of W2 from here, right? Well, you'll be getting the value of W2 approximately equal 2.92 grams, right? You'll be getting the value of W2 right here as 2.92 grams. This simply means 2.92 grams of NaCl are present in 100 ml of 0.5 molar aqueous solution, right? Yeah? Let me know in the chat box if it's clear to everyone so that I can move on and talk about few more interesting things and give you some good questions as well. Let me know in the chat box. And for the ones who have not liked the video yet, please do like the video and share the video at the same time. Yeah? And do not forget to hit the bell icon, right? Okay? Yes, I'll be completing your whole class 11th syllabus right here on this channel. Do not worry about that. Yeah? Perfect. Right? Perfect, guys. Let's move on. Let's move on to a few more things. This is something which I told you already, right? These are the two relations which I gave you already. Molarity is equal to 10 multiplied by density of solution, weight by weight percent of solute divided by molar mass of solute. The second one is molarity is equal to 10 multiplied by weight by volume percent of solute divided by molar mass of solute. These two formulas already I have given you. Yeah? Yes, Vishwesh, once this chapter is done, we'll be doing one Menti session on this chapter as well. I know you guys are waiting for the Menti, yeah? I know you guys are waiting for the Menti. Okay, perfect. Now, people, there is one more thing called as molality of solution. There is one more thing called as molality of the solution. Okay? So, right now, what was I telling you? I was talking about molarity, right? I was talking about molarity. Now, this is something which I call as molality. Okay? Noel, there is no need to derive that relation. You just need to remember that relation and put that in the equations. You should know the application of that relation. No need to derive that. Okay? No need to derive that. That does not come in your boards. Right? And if you want to derive that, that's simple. Just use the formula for molarity. Replace the volume in terms of density. You'll get the formula. Very simple. Okay? Now people understand. There is one more term called as molality, which I'm representing by small m. Okay? By capital M, we represent molarity. By small m, we represent molality. Now the point is, how do we define this term molality? Let me write its definition first. You'll get the idea of what this molality is all about. I'm writing, molality is defined as, the moles of solute present in 1 kg of solvent. Present in 1 kg of solvent. What was molarity? Molarity was number of moles of solute present in 1 liter of solution. Be careful with the things. Molarity was number of moles of solute present in 1 liter of solution, right? And molality is number of moles of solute present in 1 kg of solvent. Present in 1 kg of solvent, okay? Now people understand what all things can we depict from the term molality. Understand. Let's say I've got a solution right here. Let's say I've got a solution right here. If I've got a solution in the container, that means in this container you'll be having solute as well as solvent, right? That means in this solution, see, I've got a solution in the container. That means in this container you have got solute as well as solvent, right? Okay. Now we will see. Understand. For example, in this container, which contains a solution, right? Let's say I have got 5 kilograms of solvent in the container. Let's assume I have got 5 kilograms of solvent in the container, right? And in the same container, for example, I have got 10 moles of solute. Right? I've got 10 moles of solute. So from this scenario right here, can I say 5 kg of solvent? I can say in 5 kg of solvent, how many moles of solute are there? In 5 kg of solvent, I'll say I've got 10 moles of solute. I've got 10 moles of solute as per the scenario which I'm giving you, correct? I can say in your 5 kgs of solvent, we have got 10 moles of solute, right? Can I say 1 kg of solvent? 1 kg of solvent contains 10 divided by 5 moles of solute, right? So I got to know one important thing. These many moles of solute are present in 1 kg of solvent, right? Can I say these many moles of solute are present in 1 kg of solvent? And the number of moles of solute present in 1 kg of solvent, that defines the molality of the solution. So I got to know molality of the solution is 2. I got to know molality of the solution is 2. I got to know these many moles of solute are present with 1 kg of solvent, and the number of moles of solute present with 1 kg of solvent, that defines the molality of the solution. As simple as that, yeah? Okay? Right? Right? So I got the molality of the solution as 2, which I'm representing by small m. Okay? Well, people, one more case you can take, right? Or you can write it like this. See, I'm telling you something like this. Molality of the solution is 5. What does it mean? What does it mean? It simply means 5 moles of solute are present in 1 kg of solvent. I've got a solution whose molality is 10. What does that mean? 10 moles of solute are present in 1 kg of solvent, right? Okay? Very simple, very simple. Yeah? Now understand one important thing. See, from the scenario which I gave you right here, you got to know these many moles of solute are present in 1 kg of solvent, and the number of moles of solute present in 1 kg of solvent, that defines the molality of the solution. Now understand, this is something which I got as molality. This is something which I call as molality right here. Now people, see, in the formula of molarity, you have got numerator right here is 10. What is this 10 basically? 10 are the moles of solute, right? So in the numerator, you are going to write number of moles of solute. In the numerator, you are going to write number of moles of solute. In the denominator, you are going to write mass of solvent in kilograms, right? You are going to write mass of solvent in kilograms, which I have written over here. So you got one important result for molality. Molality is nothing, it is number of moles of solute divided by mass of solvent in kilograms, yeah? I'm sure this is clear to everyone. Hi Sashi, welcome. Right? 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 A very simple thing. Now we will understand one more important thing. See, I'm sure the concept of molality is clear, but you have to be careful with the terminology, which I'm telling you again and again. See what all things you have to remember right here. I'm writing molality is equal to number of moles of solute, we represent that by N2, divided by mass of solvent in kilograms, mass of solvent we represent by W1, but this W1 is in kilograms right here. Okay, this is one formula by means of which we can calculate molality of the solution. Yeah. Now I can convert it into a different form as well. Understand what I'm going to do? See, let's say I've got a solvent whose mass is 10 grams. I need to convert this mass into kilograms. What am I going to do? I'm going to divide it by 1000. I'll be getting the mass in kilograms, right? As simple as that, right? Now, for example, I've got the solvent whose mass is W1 grams. So I need to convert the mass of the solvent into kilograms. I simply need to divide it by 1000. I'll get the mass of solvent in kilograms, right? Yeah. Now, people, in this formula, I can write the same formula as like this as well. It's going to be N2. What is N2? Number of moles of solute, which is going to be equal to mass of solute divided by molar mass of solute. In the denominator, you have got W1 in kilograms. Instead of W1 in kilograms, can I write W1 in grams divided by 1000? This is W1 in grams divided by 1000. That 1000 goes up, so that 1000 comes over here. So this is one more formula by means of which we can calculate molality of the solution. Yeah, I'm sure it's clear to you. Right? Now, one thing which you would have noticed over here. See guys, understand properly. What was the formula to calculate molarity? Molarity was number of moles of solute divided by volume of solution in liters, or you could have written it like this: W2 multiplied by 1000 divided by M2 multiplied by volume of solution in milliliters, right? This is how we can calculate molarity. Okay, this is molality, correct? Yes, this is molarity. Where is the difference? Where is the difference? Just look at this formula and look at this formula. Where is the difference? In molarity, we use right here as volume of solution in milliliters. In molality, we use mass of solvent in grams right here. There is a difference. That's it. Rest everything is same, yeah? Over here, we have got volume of solution in ml in molarity. We have got mass of solvent in grams in molality, yeah? And people, I hope you remember, I have told you, molarity, it depends on volume, right? And volume depends on temperature. So molarity used to be temperature dependent. Molarity used to be temperature dependent. Why? Why? Because molarity depends on volume and volume actually depends on temperature, correct? But, in the formula of molality, do you see anywhere volume term in the formula? Do you see anywhere volume term in the formula? No. There is no volume term in the formula as such in molality. So can I say molality is definitely going to be temperature independent, right? Because molality does not depend on volume at all. So remember this statement as well. Molality is temperature independent. Molality is temperature independent, right? It's one more important statement. Yeah? Whereas your molarity, that is temperature dependent. Yeah? Understand. Perfect? Exactly, guys. Wonderful. Now one more important thing. Let me tell you one more direct result which we'll be using in the questions directly. One more direct result which we'll be using in the questions directly. That is the relation between molarity and molality of the solution. What is the relation between molarity and molality of the solution? I'm not going to derive this relation, neither you want the derivation. You should know how to apply the relation in the questions, okay? What is the relation first and what is its application, that I'm going to tell you afterwards. First, let's get to know the relation. Remember, molality is equal to 1000 multiplied by molarity of the solution divided by 1000 multiplied by density of solution minus molarity of the solution multiplied by molar mass of solute. This is the result between molality and molarity, which I'll be directly using in the questions. Because sometimes you get certain questions in which you'll be given with the molality of the solution and you'll be supposed to calculate molarity of the solution. Yeah, you're going to use this relation. Okay, right? Similarly, you'll be given with the molality of the solution and you'll be supposed to calculate molarity of the solution. Again, you are going to use this relation directly, right? A shallow route, yes. It's entirely your wish. If you want to go for English, you can go for English. If you want to go for Hindi, you can go for Hindi. It's completely your wish, right? And the link is there in the description box. Click on that link and use the coupon code if you want me to train you there, right? That is WSNEET. Okay. I'm sure this is clear to everyone. Let's move on. This is something which I gave you right now. Let's try to solve this question which is on your screen. Okay. Nice question this is. Nice. You need to use your brain a bit in this question. That's it. Right? Okay. People understand how will I be solving this sort of equation. Understand it properly. Okay. You might do a mistake over here which I believe you guys are going to do. Okay. Look here now. Calculate the molality of KCl solution. So you got to know first of all KCl is my solute. I've got KCl solution. That means KCl is my solute. Calculate the molality of the KCl solution prepared by dissolving 7.45 grams of KCl. Since KCl is my solute, I first of all got to know mass of solute, which I'm representing by W2, which is 7.45 grams. Right? On dissolving 7.4 grams of KCl in 500 ml of solution. So I got to know one more thing. Volume of solution is given to me as, how much? It's given to me as 500 ml. 500 ml, correct? Given that the density of the solution is 1.2 grams per ml, I'm given with the density of solution as well, which is 1.2 grams per ml. What am I supposed to calculate? I'm supposed to calculate molality of the solution. Understand the equation, then try to approach it. Understand it. Tavleen, you'll be getting. My batch is starting in this month, okay? My batch is starting in this month, then you can switch the batch as well. The batch name is Drishti B. Drishti B I'm taking. Okay. Now we will understand this question first. We are supposed to calculate molality of the solution, which is made when 7.45 grams of KCl are dissolved in 500 ml of solution, given that density of the solution is 1.2 grams ml. First of all, what am I given and what am I supposed to calculate? I'm supposed to calculate molality of the solution. Understand? I'm supposed to calculate molality of the solution, correct? And people, I hope you remember what is the formula to calculate molality. W2 multiplied by 1000 divided by M2 multiplied by mass of solvent in grams, right? This is the formula which I'll be using. First of all, in order to calculate molality, I should know this W2, I should know this M2, I should know this W1, yeah? Well, do I know the value of W2? Yes, I know the value of W2. Do I know the value of M2? What is M2? M2 is molar mass of solute, right? M2 is molar mass of solute. Solute is my KCl. So M2 is the molar mass of KCl. Potassium is 39, chlorine is 35.5. So you get the value 74.5, right? 74.5 grams per mole. Yes, you have the molar mass of solute as well. But see, this term is given to me. This term I got. But I do not know the mass of solvent yet. I do not know the mass of solvent yet. Okay? I do not know the mass of solvent. What am I going to do? I need to find out the mass of solvent. How will I be finding it out? Understand. Understand properly. See. Guys, have a look. Volume of solution is given to me as 500 ml. Density of solution is given to me as 1.2 grams per ml. Can I write something like this? Density of solution, it's given to me as 1.2 grams per ml, right? So can I write it? Density of solution, what does it actually mean? It means mass of solution in grams divided by volume of solution in ml, right? What is density? Mass by volume. This is density of solution. That's why I'm writing mass of solution divided by volume of solution. It's given to me as 1.2 grams per ml. Yeah? Now people, can I simply write it like this? Mass of solution in grams, I got to know something like this. 1.2 multiplied by volume of solution in ml. 1.2 multiplied by volume of solution in ml, that's given to me as 500. So you got the mass of solution as 600 grams. So you got the mass of solution. But are you going to use this value over here? No, this is the mass of solution. Yes. Am I going to use the mass of solution? Mass of solvent. I need the mass of solvent, right? I do not need the mass of solution. I need the mass of solvent. Well, you will understand. This is the mass of solution, which is 600 grams. If mass of solution is 600 grams, can I say mass of solute plus mass of solvent is basically 600 grams? Yeah? Mass of solution is 600 grams. That means mass of solute and solvent, okay, that's equal to 600 grams basically. Okay? Now understand. People, W1 I can write as 600 minus W2. Yeah, which is going to be 600 minus W2. W2 value already we know, that is 7.45. It is 7.45. So you get the value right here as 592.55 grams. So this is basically the mass of solvent which I'll be using in this equation. Okay. I got all the parameters. Whatever parameters were needed to calculate molality, I got all the parameters. Now put these parameters into the final equation. You're done. Yeah. I can write molality is equal to W2, which is the mass of solute. What is the mass of solute? 7.45 grams, right? 7.45 grams multiplied by what? Multiplied with 1000 divided by molar mass of solute, we already know, that is 74.5. Mass of solvent we got to know 592.55. Just solve it and get the value of molality which you were supposed to calculate. Yeah? Right. Let me know in the chat box. Give me some thumbs ups in the chat box if you got it. Thank you, Aryan. Thank you. Rohan, crash course is starting today. Today in the evening. I mean, tonight it's going to be starting, okay? Well, let me know in the chat box, people, if this concept is clear to everyone. Let me know in the chat box if you got it, how to solve this sort of equation. And for the ones who have not liked the video yet, please do like the video and share the channel at the same time. Okay? Perfect. Wonderful. Okay. Wonderful, guys. Let's try to solve one more question. So the final answer is going to be 0.168. This is going to be the molality of the resulting solution. So what does it mean? It simply means 0.168 moles of solute, or I can say 0.168 moles of KCl are present with 1 kg of solvent. That's it. Yeah. Okay, let's move on. Let's move on to the next question. One more simple question. You can solve this, I'm sure. One more simple question. Understand how to solve this question and what we are supposed to calculate. We are supposed to calculate weight by weight percent of 1.5 molar CH3COH, right? So basically we have got a solution. Basically we have got a solution in which solute is CH3COH. In which solute is CH3COH. And as per the question, we are supposed to calculate weight by weight % of solute, right? People, few minutes back, I gave you one direct result. Molarity is equal to 10 multiplied by density of solution multiplied by weight % of solute divided by molar mass of solute, right? What am I supposed to calculate? I'm supposed to calculate weight by weight % of solute, right? Well, molarity of the solution is given to me. So instead of this m, I'll be writing 1.5 is equal to 10 multiplied by density of solution is given to me 0.8 multiplied by, I'll be writing weight by weight % of solute, which I'm supposed to calculate, divided by molar mass of solute, molar mass of CH3COH. Carbon, this is 12, 12, 12, 24, 24 plus 4, 28, 28 plus 32, 28 plus 32 means 60. So 60 grams per mole is the molar mass of CH3COH, yeah? Done and dusted, right? George, let's see, bro. Exactly, Ayushi, you'll be getting the weight by weight % of solute right here. You'll be getting the weight by weight % of solute, and solute is my CH3COH. So you get the weight by weight % of solute right here is 11.2. Okay, so weight by weight % of solute you got to know is 11.2. What does it mean? It simply means 11.2 grams of solute are present in 100 grams of solution, which I told in the last session, yeah? Okay, which I told you in the last session. 11.2 grams of solute are present in 100 grams of solution, right? Right? Weight by weight % of solute I got, yeah? I'm sure this is clear again, right? Let's move on to one more question. This is one more question. Let's try to do this as well. See guys, dissolving 120 grams of urea in 1000 grams of water gave a solution of density 1.15 grams per ml. The molarity of the solution is. How to solve this sort of equation? How to solve this sort of equation? Understand. Understand properly what I'll be doing. See guys, first of all, you should know, okay, let's read the equation first. Let's read the equation first. Dissolving 120 grams of urea in 1000 grams of water. In 1000 grams of water. So I'm dissolving 120 grams of urea in 1000 grams of water. So I got to know urea is my solute. Urea is my solute. And what is the formula of urea? Formula of urea, remember NH2CONH2. NH2CONH2, this is the molecular formula of urea. Okay, so urea I'm given with as the solute and water I'm given with the solvent, right? Water is my solvent as per the question. Correct? Now people understand. Dissolving 120 grams of urea. So I'm given with mass of urea, that means mass of solute is given to me as 120 grams. Yeah? In 1000 grams of water, I'm given with mass of solvent as well, which is 1000 grams. Correct? Gave a solution of density. When I'm putting urea into water, I'm getting a solution whose density is also given to me as 1.15 grams per ml. Right? The molarity of the solution is, I'm supposed to calculate molarity of the solution. How do I do it? Understand. I'm supposed to calculate what? Molarity of the solution. First of all, what is the formula to calculate molarity? Write that. That is W2 mass of solute in grams multiplied by 1000 divided by molar mass of solute multiplied by volume of solution in milliliters, right? This is the formula to calculate molarity. Well, first of all, you see, in order to calculate molarity, am I given with all the parameters which I need in order to calculate molarity? Am I given with W2? Just check it out. Yes, I'm given with W2, right? Am I given with M2? M2 is molar mass of solute, molar mass of urea, which I can easily calculate. Molar mass of urea, if you'll calculate, it comes out to be 60 grams per mole. Yeah? So molar mass of solute already I know, W2 already I know. I only need volume of solution. But volume of solution is not given to me. How will I be doing it? How will I be calculating volume of solution? Understand. Understand, guys. Understand properly. See, first of all, I'm given with the mass of solvent, I'm given with the mass of solute. Can I calculate mass of solution? Absolutely, I can do that. Mass of solution is going to be mass of solvent plus mass of solute, right? Mass of solvent is given to me as per the equation as 1000 grams. Mass of solute is given to me as 120 grams. So I get the value 1120 grams. So this is basically the mass of solution. This is basically the mass of solution, yeah? Well, people, Is the density of solution given to me? Yes, density of solution is given to me. Can I write something like this? Density of solution, it's given to me as 1.15 grams per ml, right? Now, instead of density of solution, can I write mass of solution divided by volume of solution is actually equal to 1.15, right? Okay, so people, I'm sure you have got the idea of what to do after this. See, mass of solution, already I got to know 1120. 1120 divided by, 1120 divided by, take this 1.15 here, so divided by 1.15, you get the volume of solution in milliliters, right? So this is basically the volume of solution in ml. This is basically the volume of solution in ml, yeah? Right? I'm sure it's clear to you. Okay, you got the volume of solution in ml, correct? Simply by just using this mass of solution, we got to know as 1120 grams, right? Divided by 1.15, that's going to be the volume of solution in ml, correct? Now people, if you got the volume of solution in ml, if you got the volume of solution in ml from here, just put the volume of solution right here in this equation, you'll be getting the molarity. I can say molarity is equal to W2. W2 is the mass of solute, which is 120 grams, multiplied by 1000. Divided by molar mass of solute, that is 60 grams, multiplied by volume of solution, which you got to know as 1120 divided by 1.15. You can calculate it. I guess you'll be getting the value as 2.05. So 2.05, it is the molarity of the solution. 2.05 is the molarity of the solution. What does it mean? It simply means 2.05 moles of solute are present in 1 liter of solution. Yeah? Soumya, you have to remember the atomic masses of different elements till atomic number 30. That's enough. I'm sure till here it's clear to everyone. Yeah? Right? I'm sure this is clear to everyone. You can let me know in the chat box. Okay. Well, people, I have got 2 questions which I'm giving you as the homework. This is one question, which is your homework. Okay. There is one more after this. Oh my God, what did I do? Anyways, you try it out. Okay. This is one more question. This is one more question, which is your homework. All right. Give it a try. Give it a try. Give it a try. Exactly. Gaya. Yeah? You can do it? See guys, simple molarity of the solution is given to me. Density of the solution is given to me. I need to calculate molality. I'll be using the direct result, yeah? After that, weight by weight percent, I can calculate. Weight by volume, I can calculate. Mole fraction of solute, I can calculate. Everything I can do. Correct? So do give it a try. Do give it a try, right? Do give these 2 questions a try. I don't want to show you the solution right here. Just wait for it. Okay, fine. Solution is not mentioned over here. Alright, people. So with this, I'm ending the session. But before ending the session, let me tell you, there will be one more session on the concentration terms. That's tomorrow. Correct? Tomorrow we'll be doing something called as, we'll be doing parts per million. We'll be doing parts per billion. And we are going to talk about one of the most important topics from the concentration terms, which is what we call as molarity of dilution and molarity of mixing. Yeah? Okay? Right? Now, for the ones who are new to the channel, who have not joined the Vedantu NEET Pro subscription yet, guys, do join into this. Do get enrolled in my batch, which is starting most probably this week or maybe next week. But before that, you need to go for the registration. Do get registered in the batch, which I'm taking. The batch name is Distri B. And how do we get enrolled in that batch? You need to do one thing. There is a link in the description box of the video. Do click on the link. Use the coupon code as WSPRO while enrolling. Okay. First thing, you'll be getting the discount of, I guess, 20 to 30%. Apart from that, I'll be training you personally in both the years, class 11, class 12, as well as your NEET. Yeah. Now, at the same time, what all benefits do we have right here in this Pro subscription? Okay. Well, apart from the sessions which I take on YouTube, the actual sessions that are there in the Vedantu actual platform, right? So, people, what all benefits do we have there? You'll be getting 5,000 plus hours of live online teaching, regular tests, assignments, right? No need to worry about the test series, no need to worry about the mock tests, handwritten notes, recorded lectures, everything will be provided to you. You'll be trained personally in all the 3 subjects by the teachers of your choice, okay? And people, we have got 20 plus teachers with 5 plus years of experience who will be training you personally for the 11th boards, 12th boards, NEET 2023, everything is included over here in this Pro subscription, yeah? And you have got the option to learn either in English or in Hindi. It's completely your wish. It's completely your wish to select the language and get trained, right? Yes, Soumya, I teach for JEE also. You can check the Vedantu JEE English channel where I take the JEE batch. Okay, perfect. And people, and at the end we are going to cover your whole syllabus through the micro as well as the crash courses, right? I'm sure you guys will get go through it. Okay, so we have got 3 plans for you right here. One is light, one is classic, one is plus, right? In this light, what all benefits you'll be getting? First of all, this is the course fee for 2 years. It's not something which you have to pay annually. No, this is for 2 years. Your class 11th, class 12th, everything is included in this much amount. Yeah. So you can give it a try for a month as well. If you just want to see how it looks like, how the Vedantu platform actually looks like from inside, do give it a try for a month. Then if you'll be comfortable with, then you can go for the 2-year pro subscription. Okay. So people, do have a look on it, because I'm telling you, okay, it's going to be beneficial for you. Trust me on that. Okay. And at the same time, you can pay this fees. If you go for the 2-year program, you can pay this much of amount in the installments as well. We have got plan for that as well. You can click on the link which is there in the description box of the video. You can get to know like what all plans do we have, how you are going to break this amount monthly. Monthly you can pay this much of fees. Not this much entirely. You can break this into 2 years, right? You can break this amount of fees in 24 months. Then you can pay every month. You can pay. I guess it's going to be around 1800 or something every month. Okay, you can check it out. There's a link in the description box. You can check it out. One more thing. That's classic. What all benefits we get in classic program right here? Well, people, whatever features you have in light, apart from those features, you get the doubt solving on the mobile app, right? Whenever you feel any sort of doubt, you can write the doubt in the mobile app. You can get the answer at that time itself, right? And this is the course fee for this classic. For 2 years. It's not for single year, it's for 2 years. And at the same time, if you just want to give it a try, if you want to see it exactly how it looks like from inside, just go for 1 month. Then if you like it, then you can go for it. Yeah. Okay. And the last one, why the cost is high? It's not actually high. This much of fees we pay in offline. Yeah. I hope you remember, per year. Okay. One more thing. This is for 2 years, but at the same time, in this, you're going to get the personal mentor as well, okay? In all the 3 subjects, your physics, your chemistry, your biology. You get a personal mentor in this, guys, okay? In all the 3 subjects. That's why the price is actually high. Well, for this one, you can give it a try for a month, okay? And do give it a try. Do have a look on it, like how it looks like, okay? If you're actually liking it, okay, then you can go for the 2-year pro subscription. And how to get enrolled in these plans, how to take these pro subscriptions. There's a link in the description box of the video for the pro subscription. You need to click on that link. Just use this coupon code WSPRO if you want me to train you personally, okay? And at the same time, if you use this coupon code of WSPRO, you'll be getting some 10 to 20% off as well. Okay, so do get enrolled into this one, and the batch which I'll be taking, that's what we call as Drishti B, okay? And do get enrolled in that one, right? Where I'll be training you personally. At the same time, there is one more link in the description box of the video. That is for the Telegram. Do click on the link, get added to the Telegram group, and stay updated about the classes. And for the ones who have not liked the video yet, please do like the video, share and subscribe the channel at the same time. And do not forget to hit the bell icon at the end so you get the notification of every single session which I'll be taking right here on this channel. Yeah. It was nice meeting you. I'll see you guys tomorrow again at the same time at 10:30. Till then, you guys take care. Bye-bye. God bless you all and love you all. Take care, guys. Bye-bye. Bye-bye. Take care. Take care.